Welcome back to the Deep Dive. Today, we're zeroing in on something really unique in military history, a weapon that's, well, kind of an anomaly.
We're talking about the M2 Browning .50 caliber machine gun.
Exactly. You know, when you think about the weapons that caused the most casualties in the 20th century, your mind probably jumps straight to the big stuff.
Right, the atomic bomb, maybe poison gas, things like that. The dramatic, terrifying inventions.
Yeah, but that's, it's sort of a mental shortcut, isn't it? The actual statistics tell a different story.
They really do. If you actually tally up the numbers across all the conflicts over the last century or so, those superweapons, they account for a surprisingly small fraction of the total deaths.
Compared to what, though?
Compared to far more mundane but relentless killers. Things like disease, certainly, but also conventional artillery barrages, and maybe most significantly, the machine gun. Sustained rapid fire.
It's the quiet giant of lethality, as our sources point out. It fundamentally reshaped warfare.
Absolutely. The arrival of reliable rapid-fire weapons, especially when you combine them with things like barbed wire defenses and massed artillery, that combination basically created the stalemate of World War I.
Total stagnation, miles of trenches, static lines.
Precisely. That defensive power, that wall of lead, it just stopped armies in their tracks from 1914 to 1918. Any kind of mass infantry attack, it was just suicidal.
Which then forced everyone to figure out how to get around that problem.
Exactly. The sources are clear that stalemate directly led to the development of countermeasures we now take for granted.
Like protected vehicles.
Right.
Tanks, armored personnel carriers.
Yes, and also thinking vertically. Air mobility, airborne troops, eventually helicopters, even things like personal body armor.
All driven by the need to overcome the machine gun.
It was the central problem to solve on the battlefield.
And yet, almost all the machine guns from that specific era are now just museum pieces, replaced by lighter materials, better designs.
Newer ammunition types, technology moved on. But there's this one huge exception.
The M2.
The M2 .50 caliber. A heavy machine gun that's been in continuous production, continuous service for nearly a century. Still out there, still respected, still feared.
It's incredible. 9 decades and still no definitive replacement. That points to some serious design genius right from the start.
It really does. And it came from the mind of John M. Browning, arguably the most important American firearms designer ever.
So that's our mission for you today. We're doing a deep dive into the M2, or Duce, as it's often called.
We'll look at the history, why it was even needed in the first place.
Dig into the engineering, the mechanics of how it works.
And cover that surprising detail about its ammunition, how the bullet shape actually influenced early supersonic aircraft design.
It's quite a story.
Let's get into it.
Okay, so to really get why the M2 was such a big deal, we need to step back a bit. Look at what came before. There was this global race for firepower starting way back.
Mid-1800s, really. It kicked off after firearms got more accurate with rifling. You saw that in the Crimean War, the American Civil War.
Rifling gave you range and accuracy, but you were still limited by how fast a soldier could load and fire. One shot at a time, basically.
Right. And military thinkers realized, okay, what if we could combine that rifle accuracy with a much, much higher rate of fire? The goal became pretty ambitious.
What was it?
To give a single weapon the firepower of an entire regiment of soldiers armed with those slow, single-shot rifles. A massive force multiplier.
That's a huge leap. How did they even approach that? It sounds like you'd need something totally new.
Well, yeah, the first attempts were kind of hybrid creatures. They needed to fire infantry rifle rounds, but they were so heavy and complex they needed a carriage, like light artillery.
So not exactly portable.
Not at all. And during the U.S. Civil War, you saw some interesting, if maybe clumsy, early ideas.
Like what?
Well, volley guns. Imagine a giant shotgun firing a whole bunch of rifle rounds at once. Big blast, then a long reload.
Okay, and there are others.
Yeah, early semi-automatic types too. Hand-cranked things like the Agar gun. Got nicknamed the coffee grinder.
The coffee grinder. Because of the crank.
Yeah, and how it fed the rounds in mechanically. Looked a bit like one. But the most famous name from that era is probably Gatling.
The Gatling gun. Everyone's heard of that one.
Sure, it was a big improvement. Rotating barrels helped manage the heat, made it more reliable. A good crew could get maybe 120 rounds a minute out of it.
Still sounds pretty slow compared to modern machine guns.
It was. And crucially, it still needed that constant hand cranking. It was repeating fire, yes, but it wasn't truly automatic. That's the key distinction.
Right. Automatic means the gun cycles itself using the energy from firing.
Exactly. You pull the trigger, and it keeps going until you let go or run out of ammo. That was the next big hurdle, harnessing the energy of the shot itself.
Taking the power of the explosion and using it to reload.
Precisely.
Yeah.
And that breakthrough really started happening towards the end of the 19th century. The British adopted the Gardner gun around 1880. Still needed a crank, but the rate of fire jumped up significantly. Well, one test reportedly fired 10,000 rounds in under half an hour. That's over 370 rounds per minute, sustained. A big step up.
But still not fully automatic. Who cracked that?
That was Hiram Maxim, an American inventor, though he did a lot of his key work abroad.
Maxim gun, another famous name.
And for good reason. His 1885 design wasn't just a better repeater. It introduced the core concept that would dominate machine gun design for decades: recoil operation.
Okay, explain recoil operation. How does that work?
When you fire a gun, there's that powerful kick backwards, the recoil. Maxim figured out how to capture that energy, that rearward thrust. He designed an ingenious system of levers and springs that use that recoil force to do all the work. Unlock the action, pull out the empty shell, eject it, feed in a fresh round from a belt, push it into the chamber, lock it, and reset the trigger, all in a fraction of a second.
Wow, so the gun literally powers itself.
Exactly. That was the moment modern automatic fire was born. Maxim's gun was relatively portable, could fire close to 500 rounds a minute.
Which was like having 100 riflemen concentrated in one spot.
You got it. The Germans, the Russians, they saw the potential immediately and adopted it. That's what really set the stage for the firepower density of World War I.
But the U.S. military was a bit slower, more cautious.
Traditionally, yes. They tended to prefer homegrown designs. And that cautious approach actually created the opening for the man we're focusing on today, John M. Browning.
Okay, so Browning enters the picture. Tell us about him. We know he was American.
Born in Ogden, Utah, 1855. His father was a gunsmith, so he grew up completely immersed in firearms design and repair. Deeply practical roots.
And he started designing early on.
Oh, yeah. His early lever-action rifle designs were incredibly successful, innovative. They caught the eye of the big manufacturers.
Right, you mentioned Winchester, Colt.
And Fabrique National, FN, over in Belgium. Browning realized he was a brilliant designer. Maybe not the best manufacturer on a mass scale.
So he licensed his designs.
He formed these really strong, long-lasting partnerships. He'd provide the genius blueprints, solve the tough engineering problems, and let companies like Colt or FN handle the massive industrial side, the production, the sales, the logistics.
That's a smart way to operate. Focus on what you do best.
It worked incredibly well for him. Allowed him to just keep innovating. And interestingly, his first machine gun design wasn't recoil operated like Maxim's.
Oh, what did it use?
It was gas operated. Came out in 1895.
How does gas operation work then?
Instead of using the whole gun recoiling, it taps off a small amount of the high-pressure gas that's pushing the bullet down the barrel.
Okay.
There's a tiny hole, a gas port, in the barrel. Once the bullet passes it, some of that hot, expanding gas is vented off, usually into a tube.
And that gas does the work.
It pushes a piston, and that piston's movement provides the energy to cycle, the action eject, reload, etc. Browning actually developed that system first for an automatic shotgun.
Huh. Interesting. So he had experience with both recoil and gas systems.
Absolutely. And that 1895 gas-operated machine gun, built by Colt, actually saw service with the U.S. Navy during the Spanish-American War in Cuba.
So it worked, but he eventually went back to recoil for the M2.
He did. While gas operation was successful, especially in lighter weapons like the BAR, for a heavy machine gun firing a massive round like the .50 cal, Browning seemed to favor the sheer robustness and perhaps mechanical simplicity of harnessing the recoil impulse.
Why would that be simpler?
Potentially. Recoil is a very direct, powerful force acting along the axis of the barrel. Managing that with heavy-duty springs and levers might have seemed more straightforward, more durable for handling the immense forces of the .50 caliber round compared to tapping and regulating extremely high-pressure gas. He mastered both systems, but chose recoil for his magnum opus.
So Browning's innovating. He's got successful designs like that gas-operated gun, the BIR, which came later. But procurement was slow before World War I.
Yeah, the years leading up to the war were pretty lean for military contracts in the U.S. But Browning kept refining his ideas. Once the war started, and especially once the U.S. got involved, things changed fast. His designs were ready.
And that led to two immediate big successes, right? Besides the M2.
Absolutely. The Browning automatic rifle, or BIRR, which was a kind of a heavy automatic rifle, almost a light machine gun for individual soldiers.
Okay.
And the M1917A1. That was his improved rifle caliber machine gun. firing the standard .3006 round, 7.62 millimeter. It was water-cooled initially, very reliable.
And both of those served for a long time.
Oh yeah, variants of the BIR and the M1917 were used right up into the 1960s through WWII and Korea. Just incredibly durable, effective designs. Shows Browning knew how to build things to last.
But even with those great guns, the experience in Europe showed a gap, a need for something bigger.
A much bigger gap. The standard rifle rounds, the .30 caliber stuff, it was great against infantry in the open, but the battlefield was changing.
How so?
Two major new threats emerged in WWI that rifle rounds just couldn't handle effectively. Aircraft and tanks. Early versions, sure, but getting tougher.
Right. Fabric-skinned biplanes and those early, clunky rhomboid tanks.
Exactly, and the commanders on the ground saw this. The story goes that the specific requirement for a much heavier U.S. machine gun came directly from General John J. Blackjack Pershing in April 1918.
The commander of the whole American Expeditionary Force in Europe. He personally asked for it.
Reportedly, yes. He'd seen what the Germans were using, and he knew the existing .30 cal wasn't going to cut it against these new targets. He needed something that could punch through light armor and bring down planes.
So it wasn't just about shooting soldiers anymore. It needed to be an anti-material weapon.
That's the perfect term for it. Anti-material. It needed to destroy equipment, not just personnel. Pershing wanted a gun that could fire a massive half-inch diameter slug, .50 inches, or 12.7 millimeters.
Wow. That's a big jump from .30 caliber.
Huge jump in bullet mass and energy. But here was the kicker, the real challenge for Browning.
What was that?
Pershing wanted this monster caliber weapon, but he specified it shouldn't be much larger or heavier than the existing M1917A1 rifle caliber gun.
Wait, same size, but firing a massively bigger bullet? How is that even possible? The forces involved must be way higher.
Exactly. That's the engineering nightmare. You need much stronger parts, a beefier mechanism to handle the pressure and recoil of the .50 cal, but it has to fit in roughly the same size package.
So what did Browning do? Start from scratch?
No, he was clever. He used the M1917A1 as the foundation, scaled it up.
Yeah.
The initial M2 prototypes looked almost identical to the M1917, just bigger. They even shared the same water-cooled barrel design initially.
Water-cooled again. That points to serious heat issues with that big round.
Massive heat. Sustained automatic fire with a .50 cal generates incredible temperatures. Water cooling was the known solution at the time, but it came with a huge penalty.
Wait, right.
Immense weight. That first water-cooled M2, fully set up with its tripod and the water can and condenser, it weighed over 220 pounds.
Whoa. Okay, definitely not something you're carrying around the battlefield.
Not a chance. It limited where you could put it. Bad for aircraft, bad for vehicles that need to be mobile. Browning had to solve the weight problem.
How'd he do it? Get rid of the water jacket.
Exactly. He had to go to air cooling. But just putting cooling fins on a standard barrel wouldn't be enough for the .50 cal's heat. He needed a lot more metal to absorb and radiate that heat away.
Which led to?
The heavy barrel. The iconic feature of the M2 we recognize today. That thick, heavy barrel itself weighs about 81 pounds.
81 pounds just for the barrel.
Yep. But getting rid of the water jacket and all its associated plumbing brought the total gun weight down to about 128 pounds. Still heavy, but much more manageable than 220.
Plus the tripod, you said.
Right, the standard M3 tripod adds another 44 pounds, so you're still looking at around 172 pounds total for the air-cooled M2 system.
So even the lighter air-cooled version was always meant to be mounted on something solid.
Absolutely. Vehicles, aircraft, ships, fixed emplacements, never designed for infantry to carry into an assault. It was a heavy support weapon from day one.
That weight was the price you paid for the power and the durability needed for the .50 cal.
And the military considered it a price well worth paying. The gun immediately got a reputation for being incredibly reliable and just devastatingly powerful.
And it got that nickname that stuck, Duce.
Duce, pronounced Duce. Officially, it's the M2, of course.
Where does the name come from?
The sources suggest it's a mix. You take the M from M2, and then Duce, like the number 2 in, say, Italian, or maybe just representing the 2. Combine that with ma, like mother, or a term of endearment.
So like mother too?
Sort of. It reflects that real affection and reliance soldiers had on it. In tough situations, your machine gun was your best friend, your protector. Gunners often talked about their weapons in familiar, almost maternal terms. Duce was the dependable matriarch of firepower.
Okay, so the gun itself is a mechanical beast, built tough. But you mentioned the ammunition. The .50 BMG round is maybe even more remarkable in its own way.
It really is. The gun is just the delivery system. The bullet does the work. And the .50 cal round was special from the very beginning, right from Pershing's request.
Just to clarify again, .50 caliber means the bullet diameter.
Right, half an inch. Or 12.7 millimeters in metric. A big chunk of metal.
And the first versions were just solid slugs, no explosives or anything.
Correct. The initial requirement was for a ball round. In ammunition terms, ball usually just means a standard solid projectile. No chemical fillers, no explosive cavity. Pure kinetic energy was the goal, punch, and penetration.
How did they actually develop this brand new massive cartridge?
It was an interesting process back then. Winchester Repeating Arms got the first contract, and they apparently started experimenting using brass shotgun shells as a starting point.
Shotgun shells like 16 gauge?
The sources say 16 gauge, yeah. Trying to figure out how to build a brass case strong enough to hold that big bullet and withstand the pressure. It gives you an idea of the scale they were working with.
But Winchester didn't finish it.
No, the final design work got transferred to the U.S. Army's Frankfurt Arsenal in Philadelphia. They finalized what became the M1924 cartridge, which evolved into the standard M2 machine gun round we still use today.
And what was the final design based on? Was it totally new?
Surprisingly, no. It was essentially a massively scaled-up version of the existing standard rifle cartridge, the .306 Springfield.
They just made the .306 bigger.
Pretty much. Kept the same basic geometry, the proportions, just supersized everything.
Yeah.
Which was actually a smart engineering shortcut. They already understood the ballistics and manufacturing principles of the .3006 shape.
But you said the genius wasn't just the size, it was the shape itself. Aerodynamically perfect. That sounds like hyperbole.
Well, almost aerodynamically perfect is how the sources describe the basic M2 ball round shape. And there's a specific reason for that claim. It's all about the back end of the bullet. It has this slight taper called a boat tail.
Okay, a boat tail, like the back of a boat.
Exactly. Think about moving through water or air.
Right.
A flat back creates a lot of turbulence and drag, like a vacuum pulling you backward.
Right.
That tapered boat tail helps the airflow come back together smoothly behind the bullet as it flies. It drastically reduces that base drag.
So it slips through the air cleaner, flies farther and more stable.
Precisely. It maintains its velocity better over long distances and is less affected by crosswinds. It's a subtle but incredibly effective piece of aerodynamic design, especially for something worked out in the 1920s without supercomputers.
And this is where the connection to aviation comes in, the X-1.
This is the mind-blowing part. Decades later, in the 1940s, engineers at Bell Aircraft were designing the X-1 rocket plane, the one Chuck Yeager would use to break the sound barrier.
Famous plane.
They needed an airframe shape that would be stable and low drag at extremely high speeds, approaching and exceeding Mach 1. And what shape did they base their design on?
Don't tell me.
The .50 caliber Browning machine gun bullet.
Seriously, they modeled a supersonic plane on a bullet.
They recognized the inherent aerodynamic efficiency of that boat tail projectile shape. If it worked that well for a bullet at high velocity, the principles would scale up. The fundamental shape of the X-1 fuselage mirrors the profile of the M2 round.
That's incredible. A bullet designed for trench warfare influencing the dawn of the jet age.
It speaks volumes about how right the Frankfurt Arsenal engineers got that basic geometry back in the 20s. Pure, functional elegance.
Okay, beyond the shape, that big .50 cal size offered another advantage, right? Versatility.
Huge advantage. Unlike smaller rifle rounds, the .50 cal bullet had enough internal volume and weight capacity to carry different kinds of payloads or fillers.
So it wasn't just solid ball rounds.
Not for long. That basic ball round quickly spawned a whole family of ammunition types.
Like what?
You could put a tracer compound in the base, chemical mix that burns brightly as it flies, letting the gunner see the bullet's path and adjust aim. Very important for walking fire onto a target.
Okay, tracers. What else?
Incendiary fillers. Chemicals designed to ignite flammable materials like fuel tanks or dry brush on impact. Adds a whole other dimension to the damage.
And crucially, for Pershing's original requirement, armor piercing.
Absolutely. You could replace the standard lead core with much harder, denser materials like tungsten carbide. These armor-piercing AP rounds could punch through steel plate that would stop a normal ball round cold.
So you can mix and match these rounds in the ammo belt.
Exactly, and that's standard practice. A typical combat load for the M2 would be linked in a specific pattern, often a 5-round sequence.
What kind of mix?
Something like 2 rounds of standard ball or TP, target practice, then 2 rounds of API armor-piercing incendiary.
So it punches through and tries to start a fire.
Got it. And then the fifth round would be a tracer T. So the sequence might be ball, ball, API, API, T, repeated over and over in the belt.
So every burst has capability against different targets, plus a tracer to help aim. That's smart.
Maximum versatility and effect on target with every pull of the trigger.
And how are these rounds linked together into those belts? You see them hanging off the guns in photos.
They use something called disintegrating links. These are small metal clips, kind of springy, that hold two adjacent cartridges together.
So each link holds 2 rounds.
Essentially, yes. You clip them together to form a continuous belt of any length you need. As the M2's feed mechanism pulls a round sideways to chamber it, the link holding that round is pushed off, it disintegrates from the belt.
And the links just fall away? Are they reusable?
Yes, they fall away and they are designed to be reusable, though in combat they often get left behind. It's a much more flexible system than the old continuous cloth or non-disintegrating metal belts used on earlier guns.
And has that link system changed much over the M2's long life?
That's another testament to the design. Fundamentally, no. The M2 links used today are virtually identical in function and geometry to the ones used in World War II. Materials might be slightly better, manufacturing tolerances tighter, but the core design is unchanged.
So you could load a belt of modern .50 cal ammo into an M2 made in 1943, and it would likely run just fine.
Absolutely. That level of backwards compatibility and standardization over nearly a century is just remarkable in military hardware.
Okay, let's get back to the gun itself. We know Browning chose recoil operation. How exactly does that system handle the massive power of the .50 cal round, cycle after cycle?
It's a beautiful piece of mechanical engineering, really. The M2 uses what's called a short recoil system.
Short recoil, what does that mean?
It means that when the round fires, the barrel and the bolt, the part that holds the cartridge base, are locked together, and they recoil backward together for just a short distance inside the gun's receiver.
Okay, they move back together. Then what?
After that short rearward travel, a mechanism unlocks the bolt from the barrel. The barrel stops moving backward, but the bolt, carrying all that momentum, continues traveling rearward against a powerful recoil spring.
Oh, so the bolt keeps going back alone.
Right, and as it travels back, it pulls the empty cartridge case out of the chamber and it ejects it downwards out of the gun.
Okay, empty case is gone. What happens next?
At the rearmost point of its travel, the bolt trips the feeding mechanism, which slides the next live round over from the belt, positioning it in line with the chamber.
Got it.
Then, that heavily compressed recoil spring starts driving the massive bolt forward again.
Back towards the barrel.
Exactly. As it moves forward, it picks up that fresh round, pushes it out of the link and into the chamber. Once the round is fully seated, the bolt locks back up with the barrel, and the whole assembly moves forward that last little bit into battery.
And then it's ready to fire again.
Ready to fire again. And if the trigger is still held down, the firing pin is released, and the whole cycle repeats hundreds of times a minute. It's this incredibly violent, but perfectly timed mechanical dance.
It sounds like controlled chaos. And the gunner controls this with those spade grips and the butterfly trigger at the back?
That's the classic setup, yes. The V-shaped or butterfly trigger between the grips. You press it down with your thumbs.
And you said firing it feels powerful, like a Harley.
That's the common analogy. It's not just a sharp crack. It's a deep thumping vibration. You feel the whole heavy machine shuddering as that bolt slams back and forth. You feel the power being contained and cycled. It's visceral.
Can you fire single shots, or is it only full auto?
You can definitely fire single shots or short controlled bursts. The mechanism allows for it, and good gunnery often involves short bursts for accuracy and ammo conservation, not just holding the trigger down.
Now, you mentioned earlier, despite its toughness, it needs careful maintenance. Specifically something called headspace.
Ah, yes. Headspace. This is absolutely critical on the M2, more so than on almost any other small arm.
Why is it so critical? What is headspace exactly?
Headspace is the tiny gap, or sometimes the precise fit, between the face of the bolt and the base of the cartridge case when the round is fully chambered and the bolt is locked.
Okay, so the space at the back of the bullet inside the gun. Why does that gap matter so much?
Because of the enormous pressure generated when a .50 caliber round fires. We're talking upwards of 50,000 pounds per square inch, maybe more. The brass cartridge case has to contain that pressure, but it needs to be fully supported by the chamber walls and the bolt face.
What happens if that gap, the headspace, is too big?
If there's too much space, the bolt isn't pressed firmly against the cartridge base. When the primer ignites the powder, the brass case slams backward violently into the bolt face before the pressure builds fully. Or worse, the case can stretch excessively, thin out near the base, and potentially rupture.
Rupture. That sounds bad.
Catastrophic. If the case ruptures, those high-pressure gases vent backward directly into the gun's mechanism, potentially destroying the gun and severely injuring the gunner. It's called a case head separation, or out-of-battery detonation, which is extremely dangerous.
Yikes. So too much headspace is a huge safety issue. What about too little?
Too little headspace means the bolt can't fully close and lock on the round. The gun might simply fail to fire. Or, perhaps worse, the round could be forced so tightly into the chamber that the bolt slams shut hard enough to potentially detonate the primer, causing it to fire before it's supposed to. Also, very dangerous.
So it has to be just right. How do gunners manage that?
With meticulous care. M2 gunners are trained to check and adjust the headspace using special gonoko gauges every single time they assemble the weapon or change barrels. It involves screwing the barrel in or out by tiny increments until the bolt closes correctly on the gauge. It's a fundamental safety and function check.
That precision requirement also explains why it needs such a solid mount, right? To maintain that setting during firing.
Absolutely. The heavy tripod or a vehicle's pintle mount isn't just to hold the weight. It's to provide a rock-solid, rigid platform that prevents the gun from flexing or vibrating excessively, which could potentially alter that critical headspace setting during sustained fire.
Okay, let's talk performance. Rate of fire is around 400–550 rounds per minute. What about range? The numbers seem wild.
They are pretty impressive. There are two key range figures usually quoted. First is the theoretical maximum range,
Which is
about 4.2 miles, or nearly 7,000 meters.
4 miles. How is that even useful? You can't possibly aim at something that far away.
You don't aim directly. That's the maximum ballistic range if you fire it at a high angle, like artillery. And it has been used that way for indirect fire.
Firing over hills.
Exactly, lobbing rounds into an area to suppress enemy movement or positions. It creates what's called a beaten zone, where the bullets rain down. Not precise, but effective for area denial.
Okay, that makes sense. What about the range for aimed fire, hitting what you're shooting at?
For practical, aimed, direct fire, maximum effective range is generally considered to be about 1 mile, or roughly 1,800 meters. Some sources say 2,000 yards.
Still, a mile is incredible range for a machine gun, way beyond standard infantry rifles.
Way beyond. It gives M2 positions a huge standoff advantage. They can engage targets long before those targets are in range to effectively return fire with smaller weapons.
And up close, what's the effect like at, say, a few hundred yards?
Devastating. That big, heavy .50 cal slug carries enormous kinetic energy. At shorter ranges, it doesn't just punch holes, it shreds. Wooden buildings, drywall, sandbags, unarmored vehicles like trucks or jeeps. They just get ripped apart by sustained fire.
And against the targets Pershing wanted it for, armor and aircraft.
That's where the specialized ammo comes in. With AP, armor-piercing, or API, armor-piercing incendiary rounds, the M2 can defeat light armor quite effectively, especially at closer ranges and favorable angles.
What counts as light armor?
Things like the side, top, or rear plating on armored personnel carriers, APCs, infantry fighting vehicles, IFVs, scout cars. Maybe not the thick front armor of a main battle tank, but certainly vulnerable areas on many combat vehicles.
And helicopters.
Still a major threat to helicopters. Most helicopters, even attack helicopters, only have armor around the cockpit and critical components. The rest of the airframe is vulnerable to .50 cal fire. That's why you still see M2s used in anti-aircraft roles.
So the M2 entered service in 1919. Too late for World War I.
Just missed it. But it was ready and waiting for the massive global conflict that was brewing.
World War II.
World War II is really Duce's proving ground on a global scale. The demand was unbelievable. Every branch of the U.S. military, Army, Navy, Marines, even the Coast Guard adopted it wholesale.
For all sorts of roles.
Everything. Ground support, vehicle armament, ship defense, and, crucially, aircraft armament.
You mentioned the bombers?
Yeah, think about a B-17 Flying Fortress or a B-24 Liberator. Those heavy bombers bristled with M2s, typically 12 guns per plane, covering almost all angles. That was their primary defense against attacking fighter planes.
12 guns on one plane, that's an incredible amount of firepower.
And the fighters carried them too. The Navy's F-6F Hellcat and F-4U Corsair, the Army Air Force's P-51 Mustang. The classic American fighters of the war generally carried 6 M2s, 3 in each wing.
So it was the standard offensive and defensive aircraft gun for the U.S.?
Absolutely, which meant the production numbers had to be astronomical. Millions of guns, billions of rounds of ammunition. By the end of the war, the M2 was arguably the most produced, most widely used machine gun in the world. It dominated land, sea, and air.
It's just fascinating that here we are, decades later, in an age of smart bombs and drones, and this weapon, designed before widespread electricity in homes, is still a frontline choice. It just refuses to go away.
It really does. Its fundamental design is just that sound.
Yeah.
And, its relevance keeps getting proven in surprising ways. There's a really compelling story from the Vietnam War that bridges the gap between the M2 as a machine gun and its potential for precision.
Ah, you're talking about Sergeant Carlos Hathcock, the Marine sniper.
Exactly. Hathcock became a legend. He recorded 93 confirmed kills, many at extreme ranges for the time, and some of his most famous longest range shots were talking up to 2,500 yards. That's nearly a mile and a half.
He made those shots with an M2, not a sniper rifle.
He mounted a telescopic sight, an 8-power scope, onto a standard M2 heavy machine gun. He'd carefully select his ammunition and use the M2 in single-shot mode.
So he turned Duce, this icon of automatic firepower, into a super long-range sniper rifle.
He needed the power and flat trajectory of that .50 caliber round to make those incredibly difficult shots at distances where normal sniper rifle calibers just wouldn't have the energy or stability. The M2 was the only available platform that could deliver the .50 cal accurately enough in that way.
That's incredible improvisation. Did that influence later weapon design?
Massively. Hathcock proved the concept of the .50 caliber anti-material long-range precision rifle. About 20 years later, a gun designer named Ronnie Barrett specifically developed his M82 rifle, now famous as the Barrett 50 cal.
Yeah, everyone knows Barrett.
Barrett designed that rifle around the existing M2 machine gun ammunition. He essentially created a lighter, shoulder-fired or bipod-mounted platform purpose-built for what Hathcock had pioneered with the M2. That Barrett rifle is now standard issue across the U.S. military.
So the M2 didn't just endure, it actively inspired the next generation of heavy precision weapons.
Exactly. Its performance envelope was so broad, it opened up entirely new tactical possibilities.
Which helps explain why it's now rolling into its 9th decade of continuous service. That kind of lifespan for military tech is almost unheard of.
It really is. The core virtues range, power, reliability, relative simplicity. They just haven't been decisively beaten for the heavy machine gun role. Military professionals worldwide still choose it for those reasons.
And it keeps finding new jobs, adapting to modern threats.
Definitely. Take naval security today. The big threat isn't necessarily another nation's fleet. It's small, fast boats used for terrorism or piracy, swarm attacks.
Right, like the attack on the USS Cole.
Exactly. And what's a go-to defense against those kinds of threats on nearly every U.S. Navy vessel now?
Let me guess. M2s.
Pairs of M2s on pintle mounts around the ship's perimeter. They provide that heavy, sustained, long-range fire needed to stop those fast-moving threats before they get too close.
Still doing anti-surface duty after all these years. And on land.
Still ubiquitous, mounted on Humvees, MRAPs, tanks, Bradleys. Still the core weapon in Army and Marine heavy weapons platoons and companies dug into defensive positions.
Just like the source material says, guided missiles and even some nuclear weapons have been retired, sent to the scrap heap.
But Duce just keeps going. Outlasts weapon systems that cost orders of magnitude more.
Okay, but surely keeping a century-old design in production must be expensive, maintaining the tooling, the expertise. Wouldn't it be cheaper to design something modern?
That's the million-dollar or maybe billion-dollar question. And the answer seems to be not necessarily. Yes, there have been upgrades over the years, small improvements like quick-change barrel systems on newer variants, the M2A1.
Right, to make swapping those hot barrels easier and safer, address the headspace issue partially.
Exactly. But the core gun, the receiver, the mechanism, it's fundamentally unchanged. And crucially, the U.S. Department of Defense actively maintains the industrial base to produce brand new M2s. They're not just refurbishing old ones.
Who makes them now?
The current primary contractor mentioned is General Dynamics Ordnance and Tactical Systems, likely through facilities in Maine that used to be Saco Defense. They are delivering factory-new M2s today.
And the cost? Is it still economical?
The unit cost quoted is around $14,400. Now, that might sound like a lot, but compare it to developing, testing, and fielding a completely new weapon system to replace it.
Which would cost billions.
Billions.
Yeah.
Especially since any replacement would likely still need to fire the existing massive global stockpile of .50 BMG ammunition. So when you factor in the M2's proven performance, its incredible durability, the fact that the core gun basically doesn't wear out if maintained.
Doesn't wear out, really.
The receiver is incredibly overbuilt. Barrels wear out, some small parts might break, but the fundamental gun can be rebuilt and kept in service almost indefinitely. So yes, $14,400 for that kind of longevity and capability is considered extremely cost-effective.
That durability probably contributes to that affection soldiers have for it, too. The source comments mention that.
Absolutely. There was that mention of a machine gun instructor from the Pacific Theater and WWII, and praise for things like the Quad 50 half-track used in Korea, 4 M2s mounted together. Terrifying firepower.
You trust something that's that powerful and that reliable.
You do. Gunners often develop a real bond with their specific gun. They know its quirks, they keep it clean, they adjust the headspace perfectly. It's the tool that keeps them and their buddies alive. That Harley comparison isn't just about power, it's about that reliable mechanical soul. #tag outro. So wrapping up our deep dive today, the M2 Browning really is a story of engineering meeting necessity, born from Pershing's WWI demand for something to counter tanks and planes.
Built on John Browning's mastery of recoil operations, scaled up for incredible power but kept mechanically straightforward.
And firing ammunition that was so well designed, so aerodynamically sound, it literally helped shape the future of supersonic flight with the X-1. That's quite a legacy.
From stopping Panzers and Zeros in WWII, to providing infantry support in the hills of Korea and jungles of Vietnam, and now standing guard on Navy ships against terrorist threats, it really earns that title, almost ageless weapon.
It does. And the fact that it's still in production, still seen as the most cost-effective solution for its role, it tells you that its replacement isn't even on the horizon yet. It succeeds through its sheer brutal effectiveness and relative simplicity in an increasingly complex world.
Which leads us to our final thought for you today. Here we have the M2 Duce, a weapon nearly a century old, still manufactured, still revered by its users, engineered so well it essentially never wears out. What kind of technological leap, what fundamental change in warfare would it actually take to finally make this gun obsolete?
That's a tough question. Whatever replaces it will have enormous shoes to fill.
It seems almost certain, doesn't it? The very last person who will ever fire an M2 in military service probably hasn't even been born yet.